guys, welcome back to my channel and another video. So in this video we are going to continue with the circle part 2. I've made the part 1. If you haven't watched, then go check it out. So let's get started. So in this video we are going to talk about the chord of a circle and obviously the questions related to that as always. So basically this is the chord of a circle if you see carefully. So this is the center of the circle O, which you can see. From this till this point, you may have learned it that from the center of the circle to its circumference, a straight line draws its radius. So this is the radius, and this line which you can see, red line, becomes the chord. And this chord forms two segments, the minor segment and the major segment. This major segment is this entire kind of a semicircle. So yes, this becomes the chord. Let's look at an example so you will understand it better. So now xy is a chord of length 12 centimeters. So this is xy, we just saw what is a chord. So this becomes 12 centimeter. And radius 10 centimeter we again saw these two lines becomes the radius of 10 centimeter, and over here also 10 centimeter. Cool. And we have to calculate the angle x o y. So I will make a perpendicular bisector over here. This is a perpendicular bisector. So this angle, if it is x, then this angle becomes also x. Cool. And the center I will label as M. Now, as it is a perpendicular bisector, this becomes 90 degree. Cool enough. So we get a right angle triangle. So let the midpoint of xy be M. So xy ka midpoint F labeled M. So my becomes 6 centimeter because it's the midpoint. So 12 upon 2 becomes 6 centimeter. We know this is 10 centimeter, the radius or the hypotenuse we can say, and we need this. So in the last video only we saw about trigonometry, about sine, cos and tan. So that's exactly what you have to use. You have the opposite angle and the hypotenuse. So you have to use sine over here. So sine MOY is 6 upon 10. So now how to do? We have to sine, as in the previous video I told you have to use sine inverse. Here is the function on the right, you can see I am using sine inverse 6 upon 10. So that way I get 36.87 rounded to 2 dB. But now it is not the final answer. Why I did multiply by 2? Because as in the start I told you, we are just finding this angle. I have just founded this angle. And I told if this is x, this is also x. So you have to multiply by 2 because the question is for x, o, y and not only m, o, y. Okay. So yes, this was now the B part. There is also B part, the area of minor segment cut off by the chord xy. Now how you will find this, I will just explain you in rough quickly. Just I'll erase all this. I don't need now these things. Okay. So just quickly I will explain you the area of the minor segment cut off. So in the previous slide we saw this part is the minor segment, just this much. Cool. Now we don't have any formula for minor segment. So now what to do? If you know, we have the formula for this thing, what it is called, right? We have the formula for it. Cool enough. So we can calculate the formula for this divided by, or sorry, subtracted by the formula of this triangle. Cool. And there is also formula. You can use any formulas of the triangle, maybe half into base into height, but that you have to multiply it by 2 again because it's not a right angle triangle. Basic formulas you can use. You can use also complex formulas. Maybe also use the formula with sine. This all I haven't shown in any of the video, but yes, it is there out if you check out the formulas for triangle. So you may refer from there too, But don't worry, I'm showing in the next part what has to be done. So yes, that's exactly what I have done. You can see the calculator also on the left hand side, exactly what I am doing with the calci. It's with the calci. So, and this is the scientific calculator you have to use, and I've just changed the value to decimal. It was coming in pi, I changed it to decimal, 64.3 approximately. So the area of the sector, and this is the triangle ka. As I told you, half into A into B into sin C, it would be very easy to use half into A into B into sin C. Okay, wait, I will show you. Let just this calculation get over, then I will show you what is half into A into B into sin C. And you get 48 over here. And then simply subtraction of the minor segment, because you just had to find this much area out of the whole, right? So you get 16.32 over here also. 32 I have done till 1 dp only. So what is this half into A into B into sin C? So if this is a triangle, I want it easy. It's not a right angle triangle. Right angle triangle, half into base into height. You can use half into base into height over here also, but in that you have to multiply it by 2. So in this what you will do, so for example you have this angle with you ready, which we just found in the previous step, and you have these two other sides, 10 and 10. So basically it is something like this. So this is A side, this is B side, and this is C side, and this is C angle also, and this is A angle, and this is B angle. So half into A into B into sin C. That's what we do. So yes, cool. Let's move on. So now it's time for actual solving. You can read the question over here. It's written, how far is the chord of length 8 centimeter from the center of the circle of radius 5 centimeter. So I first actually drawn the circle with the measurements. Now this was a very easy question. You can do it or even orally, but you can see on the right I've shown it on the calci also. It's logical. 3 square plus 4 square is only 5 square. There is no other answer to it, but still you can see it. I've directly subtracted it, not done everything. 9 and square root of 9, you get 3 as the answer, which is the final answer over here too. This is the triangle I am taking. Once again I will explain you in the easy method. This is the center. How far is the chord of length? 8 centimeter. Chord 8 centimeter. Radius 5 centimeter. What you have to find is how far. This length, this distance you can say we have to find. So yes, that's exactly what I found over here. OM. Cool enough? Let's move on. So this question you may pause it. This is a bit complex. Not actually complex, but you can try this question. A regular hexagon is circumferenced by a circle of radius 6 centimeter. Find the area shaded. Just the area shaded. One trick I can give you, take separate sectors. What I mean is like this. And if you have a bit knowledge of shapes, it's very easy to find this angle. And maybe this and this and this and this. Try finding it. You may pause the video now because I'll be showing you the solution now. So a regular hexagon is circumference in a circle with a radius 6 centimeter. So it is inside the circle. By joining the opposite side, it forms 6 central angles and center O, which I exactly showed you. So it's inside a circle, so it's 360 degree. You must be knowing it. Divide by 6, so 60 degrees. So each angle becomes 60 degrees over here. And 6 triangles are formed. The two sides of each triangle are the radius and thus are equal. So this and this are equal. So 6 centimeter, 6 centimeter. Cool enough. Now the base angles of every triangle are equal. How I got this? Because it's 60 So now these two angles, the other two angles, I will just mark and show you so it's clear. These two angles are basically 180 minus 60 upon 2, that is 120 upon 2, that is again 60. So coincidentally this becomes an equilateral triangle and all sides will be equal. So this is also 6 centimeter. So each side of the triangle is 6 centimeter. So now over here you can see the area of the circle I am finding. The entire area of the circle pi r square you have to use, and on the calculation also I am showing you over here pi r square I have to use. How to use, you can see the button is getting highlighted. 6r square. This is simple formula for circle pi r square. So I get 36 pi, which is nothing but 113.1. So basically this is the decimal difference which is coming up, nothing else. So yes, so now let's see the next. We have got the area of the circle. Now what? We have to just find the area shaded. Now what? Let's see. The area of the hexagon we have to find. Now how we'll find the area of the hexagon? You might not be knowing the actual formula of the area of the hexagon, so you may use the 6 into area of each equilateral triangle. So now this formula you might find complex, that much I have used for the triangle, but on the right I am showing you that same formula which you used half into a into b into sine c. You can look at 6 into 6 into sine 60. Sine 60 you will get same 9 root 3, which is nothing but this 93.42. I've also done directly into 6, so I get 93.5. Okay, simple decimal ka farak. I have done this on actual calci. This is what I get over here, because your decimal ka there would be a farak. Nothing much. So yes, so I get 93 point, let's say 93.5 or 93.4. Anything is fine. The final answer is what it matters. The shaded area becomes the area of the circle minus area of the hexagon. As simple as that. It's all done. You have got the area of the circle first. Now you have got the area of the hexagon. Simply subtract it and you'll get the shaded area. And just showing this simple calculation on the calc. There was no need, but yet I have shown you it's coming correct. See the final, though there was a difference of a decimal and all such things, the final answer we got the same. Simple. Thank you guys. That's it for today's video and also for circles. I guess I don't think so there is anything left. If left, I will make the next part of the videos also, but as you may have seen in the start of the video also, I have put the like target this time. For the first time there is a target of 5 likes. Now why 5 likes? I will share this exclusive PDF made by me on the description below only if I get 5 likes. So go like the video, and if you haven't subscribed, subscribe man, subscribe. Yes guys, that's it. Thanks for watching. Bye bye.